Cooking changes pesticide residues in food, but not in a clean, predictable way that allows us to relax completely. Heat, water, fat, and time all interact with chemical residues differently, and while some cooking methods do reduce certain pesticides, others simply redistribute them or leave them largely untouched. The uncomfortable truth is that cooking helps, but it is not a chemical eraser, and its benefits come with nutritional trade-offs that matter. Boiling is often assumed to be the most effective method because it involves water, dilution, and heat. In reality, its effectiveness depends heavily on the type of pesticide. Water-soluble pesticides can partially leach out into the cooking water, which does reduce the amount left in the food itself. This effect is more noticeable in vegetables cut into small pieces, where a larger surface area allows more contact with water. However, this reduction only applies if the cooking water is discarded. If the water is reused in soups or sauces, the pesticide residues are not eliminated, just transferred. More problematic is that many modern pesticides are not highly water-soluble, meaning boiling has little impact on them. At the same time, boiling is one of the most aggressive methods for nutrient loss, particularly for vitamin C, B vitamins, and some polyphenol, which are precisely the compounds that make vegetables protective for health in the first place. Steaming is often promoted as a safer and cleaner option, and nutritionally it usually is. Because the food does not sit in water, fewer vitamins and minerals are lost, and texture and flavor are better preserved. From a pesticide perspective, however, steaming is less effective than boiling at removing residues. There is minimal leaching, so any reduction relies mostly on heat degradation. Some pesticides do break down at high temperatures, but many are designed to be relatively heat-stable to survive environmental conditions. As a result, steaming may preserve nutrients better, but it also preserves more of the original pesticide residue profile compared to boiling. Frying introduces another layer of complexity. Pesticides that are fat-soluble can migrate into cooking oils, which might reduce their concentration in the food itself. However, this does not mean the exposure disappears. It simply moves into the oil, which is often consumed along with the food. High temperatures can degrade some pesticide compounds, but they can also transform them into breakdown products that are poorly studied and not necessarily harmless. From a nutritional standpoint, frying also alters the food matrix, increasing energy density and sometimes generating harmful compounds, which complicates any small benefit from residue reduction. An important limitation across all cooking methods is that pesticides located inside plant tissues are much harder to remove. Systemic pesticides, absorbed during growth, are distributed throughout the flesh of fruits and vegetables. Cooking affects the surface far more than the interior, which means that even aggressive methods cannot eliminate these compounds completely. This is why cooking should be seen as a secondary defense, not a primary solution. Another often overlooked issue is cumulative exposure. Even if cooking reduces pesticide levels by 20, 30, or even 50% for certain compounds, that reduction applies only to a single food, prepared once. Over time, repeated consumption of cooked produce still contributes to chronic low-dose exposure. The risk is not dramatic in any single meal, but biology does not reset overnight. Small reductions help, but they do not neutralize long-term accumulation. From a nutrient perspective, there is a clear trade-off. Methods that are harsher on pesticides tend to be harsher on vitamins and antioxidants. Methods that preserve nutrients tend to preserve residues as well. This creates a false choice between cleaner food and more nutritious food, when in reality the best strategy is upstream, reducing pesticide use during production rather than relying on cooking to fix the problem later. The most realistic conclusion is that cooking can modestly reduce certain pesticide residues, especially when combined with washing, peeling, and discarding cooking water. But it does not make heavily treated produce equivalent to low pesticide or organic options, and it does not remove the need for regulatory control or informed food choices. Cooking improves safety at the margins, not at the root. Seen this way, Cooking is a useful but limited tool. It protects against microbes very effectively, but against pesticides it offers partial, inconsistent protection, often at the cost of nutritional value. Treating it as a complete solution creates a false sense of security, and in matters of long-term health, that illusion is often more dangerous than the residues themselves.